Now guys, let's talk about rectification. So you have to read all this by yourself. So we start with rectification now. So rectification is the conversion of AC to DC. Conversion of AC to DC. You know your phone is using DC. So you use your charger to charge your phone. You connected your charger to your socket. The power supply at the socket is AC. So the charger converts it to DC. So that means the charger performs what we call rectification to generate DC for your phone. So if you want to do that, so we use rectifier, which is rectifying diode to achieve that. So you know AC is a sinusoidal wave. So it moves like this from 0 to positive half cycle to negative half cycle, back to positive half cycle, back to negative half cycle. That's how it moves. So from 0 to under 0, so that's one cycle. So the positive side is positive half cycle and the negative side negative half cycle. You know, diode allows movement of current. It allows a unidirectional movement of current, right? So that means it allows positive to move from this point to this point. It allows positive to move from this point to this point, and doesn't allow negative to move. You know, current move from high potential to lower potential. That means from positive to where? To lower potential to negative. So when the wave is at its positive half cycle, so that means here will be positive and the other side will be what? It will be negative. So it will allow positive current to pass through it. Hope you're getting it. So, but during the negative half cycle, it won't allow it to pass through it. So now for this a half wave rectifier, so just one side is being rectified. So that means just one side. That means the positive cycle is the only side that is being rectified. So, but for if the dual half wave rectifier, you know, during the positive cycle, positive will pass through this diode. And during the negative half cycle, current cannot pass through this diode anymore. So then it will pass through this other one. You know, at the negative half cycle, this will be negative, and the other side from the other end will be positive. That current will flow from here to here. So that will be a movement of current, right? So, but for this one, the current will not move during the negative half cycle. So that's for dual half wave rectifier. So now let me show you the simulation. So this is a bridge rectifier. Bridge rectifier is like the one I showed you the other time. Okay, this is it. This is the component. So the AC component, this AC, 2AC, is where you connect your AC footage to. So the quality that's coming from your power supply, from your sockets, or from your step down transformer. So we still discuss transformer and the types of transformer. So for now, these two terminal, you connect the AC footage to it, and you get back your DC footage from these two extreme terminals. So positive, negative. The one that has curve is the positive, while the one that is straight is the negative. So, and for this type, it is already labeled. So let's go back to the simulation. So this is the AC terminal. So identify AC terminal on circuit on circuit diagram. So the one that has the end that has connection of opposite sides is AC. This one is opposite of this. They are connected together. So this terminal is AC and this terminal is also AC. That's where you connect your AC source too. And for this one, and the one that has the same terminal, like this, cathode. So cathode, what will come out from cathode will be positive, and what will come out from anode will be negative. You're getting it? Because positive can move like this, pass through this, and come out like this. Positive can move like this during the positive half cycle. During the positive half cycle, it's a move like this, pass through the anode and come out. That's positive, right? So and during the negative half cycle, so it's a move like this, so move like this, so to come out. So negative and positive. So you can read more on bridge rectification to understand more about it. So now let me okay, after rectifying it, so from here to here, this AC, so this is a transformer. So we call something experimental transformer. So they are used in laboratory. So it converts a step down or step up voltage. So since this one is 10:1, that means it's step down voltage. So this is step down transformer. That means if 220 volts get to this point, you have what? We have 22. You have 22 volts output here, but it will still be AC because you have not rectified it to DC. So that means what's coming out from the transformer is AC, not DC. So, but for a center tap transformer, you will have something like this there. So what this means is that if you connect this terminal to this, like if you delete this, okay, let me connect a voltmeter to it first. So a voltmeter, okay, let's connect voltmeter to it. Yeah, okay. Now let's play it. Now we have 6 point something, right? 6 point something, varying from 6 point something. So let's connect it to this point instead of this point. So now we have now we have 3 point something. So the principle behind a center tap transformer is that if you connect the two extreme ends, if you use these two extreme ends, so you have a full output. But if you connect the center with one end, you have half. Depending on the windings, you have half of the output. So you know now you have 3 point something, and the other time we have 6 point something. That's how center tap transformer works. So I will actually show you this in real life. I will connect it and send the video. So this is a bridge rectifier. So after rectifying it, the output won't be stable. So there will be some ripple there. So you will need to stabilize it or to filter it. That's why we use electrolytic capacitor to filter it. Connect the positive terminal to this point and negative terminal to this point. So let me show you how electrolytic capacitor looks like. Okay, welcome back. This is an electrolytic capacitor. So this side that has a white color or gray color, so is the negative side, and this is the positive side. This is negative side, this is the positive side. So let's go back to the simulation. So that means to connect the positive side to this and the negative side to this, the one that has a white color. So the output then will be filtered. But for you to use a capacitor to filter the output of your rectifier, you have to consider two things. The first thing is the voltage rating of the capacitor. So the voltage rating must be at least like multiply by 2 of the output footage that you are expecting. Multiply by 2. Now our output footage, I think, is like 3 point something. So the footage of the model should be something like 16 or 10 or 35. So minimum, that's the minimum. It can be more than that. So, and you have to have a high capacitance so that the footage, the output will be well fitted. So now let's have like 220, 2200, okay, that's 100 megafarad. So now let's play it. So it's more stable compared to the other time that we have, that will be flowing from 2 to 4, 2 to 3, something like that. So that's how to rectify. This is a full bridge rectification. So you can read more on that. So you can simulate it further, do this footage doubler, bridge footage doubler, and so on and so forth. So you can read more on rectification. So that's all for that. And for the capacitor, I will record a short video on it, because we don't really need to go deep on capacitor. So